So, today we will discuss about the last module, last part of this micro systems for micro robotic related developments. Basically, like we have been discussing about the different actuator based systems. So, we have been discussing about piezoelectric based, ultrasonic based, we have also discussed about micromotors, etc. And in the last class we had discussed about this thermal based actuation. Now, in today's lecture we will discuss about the chemical micro engines. So, as far as these chemical micro engines are concerned, so these chemical micro engines, they derive their power from chemical reactions which are often mimicking the biological system. So, some of the examples includes the catalytic engine. So, in the case of a catalytic engine, so ideally the surface reactions are taken into consideration to generate the motion in the fluids, and then there are certain osmotic engines are also getting delivered. So, these osmotic engines are highly used for harnessing the osmotic pressure differential within the system, and there are some fuel based engines which is mainly meant for converting the chemical energy directly into an electrical and a mechanical energy. So, these engines offers the potential of autonomous operation in a specific environment, which is one of the key aspect which we may need to take up while we are using such kind of engines. But like where there is an issue of fuel storage, and then there is a reaction of control at the micro scale. So, ideally let us consider like in a certain amount of chemical reactions or in the kind of chemical plant where such kind of systems can be deployed, where it can be used for propelling or actuating the micro robots for different applications. However, on a research perspective point of view, there are very less focus in this particular domain. So, ideally owing to its challenges which are being involved in it. Next, one of the key domain is the optical based micro engines. So, as far as the name suggests that, so optical micro engines uses light energy to generate motion either directly through photon pressure or indirectly through photothermal effect. Some of the examples which basically includes optically driven micro turbines, light activated polymer actuators, photovoltaic power based micro engines. So, as far as these optically driven micro turbines are concerned, let us consider. So, we have a small micro turbine which is fabricated using a shape memory alloy. So, the overall fins of this micro turbine is fabricated using a shape memory alloy, and these shape memory alloys are highly strained during the fabrication. Now, what happens is when the laser light is made to interact on this micro turbine, these micro turbine will try to get actuated. When these micro turbine gets actuated appropriately, there is going to be a kind of a shift in the center of gravity which will result in a kind of a rotation. Okay. So, like the overall actuation is done using a kind of an optical mean, so that the light which is incident on this surface is completely absorbed and it acts as a source for actuation. So, this is one mode in which, so we can have a kind of an actuation through a light. In most of the cases a monochromatic source, ideally lasers will be used for such kind of actuation for efficient rotations. Then we have the light activated polymer actuator. So, in fact, when we were studying about the different type of actuators, so we have seen some of these kind of light activated, that is light activated polymers. So, these polymers, when the light interact on it, it tries to get displaced. When the light cut off, it comes back to its shape. For example, let us consider we have a light activated polymer like this, which is being trained in a ohm shape. Now, what happens is when the light falls on it, it becomes straight. So, ideally we are trying to switch between one shape to another shape based on our requirement or based on the propulsion for a specific applications. So, here the actuation is the light. So, the on and off of the light will have a direct control over the movement of these structures. So, these are called as a light activated polymer actuators. Then there are certain amount of photovoltaic powered micro engines. So, as far as these photovoltaic powered micro engines are concerned, so these are kind of solar cells which are being available. So, when the light falls on it, appropriately the energy is going to get generated. So, these energies are capable enough to generate to actuate the micro engines based on the requirement. So, one of the key advantage of using this particular system is it offers a kind of a non-contact actuation. This is one important point. Another point is these optical micro engines typically provides a low power output compared to the other types. So, like as far as actuation perspective point of view, a precise actuation is possible by appropriately shining a light in a particular point. So, as we all know, if we need to have a concentrated beam, appropriately we may use a lens system to focus the beam in that particular point, and then appropriately we can actuate it. So, ideally what happens is a control of the actuation is well taken care using this particular optical based system, and appropriately we can expect an actuation. Now, this is quite an interesting problem. So, in this it is a kind of a design in which, like it is a kind of a split comb drive design which is completely fabricated using a light actuated polymer. So, basically these polymers are integrated in the form of split comb drive, and then this split comb drive ideally allows the waveguide to be placed near to the translation stage when other features such as extended counterweight on the micro engine and the linear actuators are not available. So, the multi-mode waveguide design includes a polymer substrate layer. The isolating nitride layer of a typical such kind of SMM structure process and relies upon variation in the reflected power coupled back over the moving stage into the waveguide input, which is subsequently split and collected output. So, as far as in this particular case is concerned, we have an optical input, and this optical input is made to pass through a multi-mode wavelength. So, if you see the construction of it, this is a kind of a like comb drive based polymer structure which is available. As and when once the light falls on it, there is going to be an actuation which exhibits. So, like it is something like this with reference to time t. When the intensity increase, there is going to be a increase in the displacement, and then there is going to be a drop. Okay. So, like this, if I try to term it as a d, so this is going to be a like the intensity, let us consider it as on and off, on and off. So, when the intensity is on, we get a displacement, and when there is a intensity is off, there is going to be a decrease in the displacement. Again, when there is an intensity is on, there is a displacement, and then there is going to be a decrease in displacement. So, this switching behavior can happen within this system. So, that is why it is a kind of a resonator which is being fixed over here, so that appropriately like we can have a control over the frequency, and by controlling the frequency we can use it for different applications. Like for example, so by giving a particular sequence, so I can load a kind of a cantilever on top of it, and this cantilever can be vibrated appropriately with this resonator. Okay. So, the on and off of the light will take care of the requirement, and appropriately you can see a movement coming out of it. So, these are some kind of polyimide wave gates which are fabricated in the form of a kind of a split comb resonator, and the actuation is through a laser or is through a light. Now, let us just brush up some of the different fabrication techniques which are being deployed for developing such kind of micro engine related applications. So, as far as these micro engines are concerned, so with reference to different micro engine, these are the different fabrication techniques which are being effectively used. So, either it might be a laser based micro machining, or in certain cases there is a chance for going for a mechanical micro machining. A lithography based system is a highly effective system. A 3D printing at a micro scale can be effectively used, and there are certain amount of surface micro machinings can also be employed. As far as these material selection for micro engines are concerned, so these material selections for micro engines are critical, balancing, and it has a balanced mechanical properties, and it has a good fabrication compatibility and application requirement. Some of the common material includes the silicon, which is basically we have quite a good amount of database with reference to silicon, which has a excellent mechanical properties and an established fabrication process. With reference to metal perspective point of view, we have the nickel, gold, good etc., which has a good conductivity suitable for electromagnetic engines. As far as polymers perspective point of view, we have a SU8 and a PDMS structure, and then there is a flexibility and a biocompatibility. As far as piezoelectric perspective point of view, there are wide varieties of material which exhibit piezoelectric capability. Recently, lead free zinc oxides are also been efficiently used for piezoelectric related applications, and then there are certain amount of shape memory alloy materials are also there which are being exhibited. Now, let us discuss about some of the key design considerations for and optimization relevant to this micro engines. As far as for effective micro engine design is concerned, it requires a careful consideration of various factors. So, some of the factors includes power output and efficiency requirement, operating environment, temperature, humidity and chemical compatibility, fabrication constraint and material limitations, integration with control and power systems, reliability and lifetime expectations is one of the key parameter. So, as far as these optimization perspective point of view, these optimization often involves a multiphysics simulation considering a coupled electrical, mechanical and thermal effect at a micro scale. So, these are some considered to be some of the key design considerations which are effectively participating to develop a micro system for the appropriate functionalities. Now, as far as these micro engines are concerned, so these micro engines play a crucial role in the development of micro robots. So, one of the crucial role includes a locomotion mechanism for terrestrial micro robot, an articulated joint for micro manipulator related application. So, as far as these locomotions are concerned, so either it might be a stick slip based or sometime it might be a comb based, and there are some mechanisms where with reference to vibration, with the high frequency vibration we can have a kind of a locomotion, like if we can have a structure something like this, it is a kind of a cantilever. When these cantilevers vibrate at a very high frequency, this will induce a kind of a forward motion to the system. Next is a kind of an articulated joint for micro manipulators, so which is considered to be one of the effective way where giving an appropriate constraint to it will give a kind of input with reference to a different reach out. So, which is considered to be one of the key point. Next is the kind of a propulsion system for swimming micro robot, and then the power source for autonomous operation. So, like as far as these autonomous operations are concerned, even though we had discussed about some kind of micro energy harvesters, still there is a need to work upon the overall characteristics and the behavior. So, this is one of the key aspects which we may need to look into it. Okay. Now, as far as these challenges are concerned, it has an improved power density and efficiency. It has a good enhanced reliability and lifetime. When we try to look into the overall fabrication cost, there is a reduction in the fabrication cost, basically with reference to a mass production, and integrating a multiple functionalities in a single device is considered to be one of the key challenges in this concern. When we try to focus upon the future directions, exploration of novel material like example 2D materials, meta materials are considered to be one of the key directions which we may need to focus upon for with reference to micro robotic perspective point of view. A bio inspired and soft micro engines is one of the domain. Self assembling and reconfigurable micro engines is considered to be one of the domain. Integrating with artificial intelligence for adaptive behavior is one of the key aspect, like either with reference to propulsion mechanism perspective point of view, we have different domains. One domain is with reference to steam, the other domain is with reference to a liquid. In certain cases we may also need to go for a magnetic field based systems. In those conditions, such kind of adaptive behavior will help for an appropriate to fulfill some of the appropriate functionality. As far as biomedical application perspective point of view, micropump we have seen a lot. So, when we try to closely observe these micropump for drug delivery related applications, so the micropump for minimally invasive surgeries, It has an artificial muscle for prosthetic related applications, and a microfluidic device for a lab on chip diagnostics, and a implantable sensors and actuators. So, as far as these micropump for drug delivery system, so it has a kind of a like a, one good aspect, one of the key aspect which we may need to look into this micropumps are, like we have seen one case study also where we could observe that ideally for targeted drug delivery related applications and for implantable related applications, such kind of micropumps can be efficiently used. Now, if we try to look into the strategic areas where such kind of micro engines contribute. So, since micro engines contribute to the miniaturization and enhanced functionality in aerospace and defense application. Some of the aspects includes the micro thruster for satellite positioning, like so ideally wherever based on the requirement such kind of adaptive micro thrusters get activated and it can be used for locomotion of the satellite. Second, adaptive optics for imaging system. So, this is considered to be one of the key domain. So, where there are a good amount of research which is focused on this optomechatronic systems. Further, more focus is there on micro optomechatronic systems, where such kind of micro engines or the micro actuators are integrated with an optics, so that the overall focal point of the optics can be manipulated. So, like the required focal point can be manipulated to get the required application. Like one good example is currently about this autofocus which is available in the cameras. So, these autofocus basically works on the principle like we have a kind of an image stabilization program. Based on the image stabilization program, the actuator moves and appropriately it will try to get the signal coming out of it. From these signals we can observe the overall like construction behavior, etc. Then there are certain amount of micro gyroscopes which are used for navigation related applications. So, as far as these micro gyroscopes are concerned, see these micro gyroscopes are effectively used for kind of stabilization perspective point of view. So, energy harvester for autonomous sensors are also considered to be one of the key elements which are effectively used for autonomous related applications, and a microfluidic cooling system for electronics. So, like ideally wherever we have a kind of an electronic system, such kind of micro actuation with the microfluidic behavior will have its own advantage for taking care of adaptive related structures. Now, when we focus upon the energy harvesting related applications, so micro engines play a role in micro scale energy harvesting, ideally with reference to the power generation. So, with reference to power generation perspective point of view, so we have a vibration based energy harvesters. So, where like it might be a kind of a piezoelectric based system. So, from the vibration we can harness the energy. Then there is a kind of thermoelectric based micro engines, like because of the variation in the temperature gradient appropriately we can get these structures. Then there are few micro fuel cells which are available, and then a piezoelectric energy based scavenging devices are being effectively used for micro robotic related applications. So, these technologies ideally aim to develop a self powered microsystem for applications like wireless sensor network and implantable medical devices are some of the key applications where such kind of energy harvesting and power generation related applications are focused. As far as application perspective point of view, in the case of application in MEMS devices concerned, the integration of micro engines, it enables a MEMS device to perform a complex function in compact form factor. So, some of the systems, some of the microsystems are listed over here. So, one important microsystem is the kind of a micro pump which has a valves for fluid control. And then there is a kind of a micro actuator which is ideally used for a kind of a precise positioning. There are few energy harvesting devices which are being effectively used for like harvesting related applications. So, there are several micro energy harvesters. And these harvesters has a potential application in harvesting energy from thermal, from vibration, from shock, and sometime from chemical reactions also. Then we have the inertial sensors, which are effectively used for motion detection related applications. So, which is considered to be one of the prime focus in the case of micro robotics is concerned. Even a sudden change or in the minor change in the system can be effectively monitored using this arrangement. So, ideally motion detection are sensed either in most of the cases through cameras. However, in this particular case we have a capability to use a kind of an inertial system which can be effectively used for monitoring this system based on the applications. Okay. Then we have the micro mirror arrays for optical switching and display related applications. Like such kind of micro mirrors are concerned, like we can have a kind of a switching behavior. So, these switching behavior can be effectively used for the movement of the system, and then we can see we can divert the beam for certain amount of like optical manipulation related applications. So, in those areas, so such kind of micro mirror arrays are also available. If you remember, we had discussed about this. So, we were discussed about this SMA based high reflectivity mirrors. So, these SMA based high reflectivity mirrors are integrated with a kind of a Stewart platform kind of arrangement, and here we have a kind of an SMA bimorph. So, this SMA bimorph is effectively used for operating in such a way that, so this actuation moves and appropriately, like we can see a kind of a deflection, and we can also monitor the deflection. Okay. So, there are like micro pumps and micro valves for microwave, which we had discussed in detail. Okay. Now, let us discuss about one of the key aspect, which is called as magnetic helical based micro missions. So, as far as these magnetic helical based micro missions are concerned, this is considered to be a kind of a nave system. It's a kind of a system which is like which is effectively used for displacement related applications. So, ideally such kinds of systems are inspired by a bacterial flagella. So, and these micro mission utilizes a helical propulsion mechanism to perform tasks such as cargo transport, biofilm disruption and drug delivery. So, in this particular case, so there is a kind of a helical kind of arrangement which is there. So, this helical propulsion will be helpful for us in such a way that, so whenever we try to actuate it, when the helical rotation is there, appropriately we can expect a kind of a displacement which exhibits over here. So, if we try to look into the application perspective point of view, it has a potential application towards biofilm disruption as well as towards targeted drug delivery. So, there are three different, there are as far as the mode perspective point of view, it has a helical shape. It enables a kind of a corkscrew like motion for efficient propulsion. So, basically this corkscrew motion is the overall principle for this helical shape. Then there is a kind of a magnetic actuation which exhibits. So, these are kind of powered wirelessly using rotating magnetic field. So, as and when we try to actuate the magnetic field, so appropriately there is going to be a rotation which persists. Versatility perspective point of view, it operates in a diverse fluid environment which including a water, a bodily fluid and a tissue, which is considered to be one of the key advantage in using such kind of magnetic based helical micro machines for the different applications. So, for propulsion and manipulation in fluid environment, using a low strength, a rotating magnetic field which can be considered harmless to human or other living organisms. So, as far as in this particular case, it has a kind of a, it is driven by a rotating magnetic field that generates a torque on the magnetized helical body. This results in a kind of a corkscrew motion, allowing the micro machine to swim through the fluid efficiently. So, such kind of system will be integrated with cavities and can carry drug to a specific location within the body. So, this is one advantage of this particular system, and they are precise control, and it allows a localized delivery without damaging the surrounding tissue, which is considered to be one of the key aspect of this system. As far as these helical propulsion mechanisms are concerned, it has a low Reynolds number dynamics. It operates in an environment where viscous force heavily dominates. As far as this corkscrew motion are concerned, it converts a rotational motion into a kind of an appropriate translation motion, and efficiency factor perspective point of view. So, some of the key parameters which are involved in this are the helix pitch, the diameter, the magnetization direction, which influence the propulsion speed, are considered to be some of the efficiency parameters. So, some of the key factors on magnetic actuations are the motion of a microorganism in fluid is different from that of microorganisms, that can be explained with the kind of a Reynolds number. So, we all know as far as Reynolds number is concerned, it is a ratio of inertial force to the viscous force. L and U are length and velocity of this helical system, and rho and mu are the fluid density and viscosity which are participating towards this system. And L and U values of HMR are in the range of 10 power minus 6 to 10 power minus 4, and with reference to the different parameter. So, like overall Reynolds number is less than 1. So, to achieve an effective non-reciprocal propulsive motion in a low Reynolds environment, bacteria uses their rotating helical flagella for translational corkscrew locomotions. Now, as far as working principle perspective point of view, this magnetic actuation is generally produced by exerting a magnetic force or a magnetic torque on the machine by means of a time varying or a spatially varying magnetic fields. So, when we try to look into these magnetic forces, so let us consider let us represent the magnetic force as Fm, and then we have Vm is the volume, M is the magnetization, B represents the external magnetic field. So, ideally when we try to look into this magnetic torque, so in this magnetic torque we have the volume and the magnetization, and B which is getting represented in the magnetic field. This is generated by a continuous alignment of the magnetization of axis and the direction of the applied rotating field. So, this continuous rotation of this system produced by a magnetic torque generates a motion in the direction perpendicular to the plane of the rotation due to the rotation translation coupling. So, this is going to be the V and this is going to be the magnetic field B. So, the motion of this HMNMN under rotational magnetic field is primarily determined by two aspects. One is called as a magnetic field control system. So, as far as in this magnetic field control system is concerned, a magnetic field strength with velocity of the helix MNM increases the field strength. Direction angle of magnetic field is to adjust the movement direction HM, and its angle is component of direction angle that makes it to tilt at a certain angle from their origin, horizontal state, producing a vertical propulsion component to compensate the gravity force, which ensures a kind of a free swimming. So, ideally the direction is related with the propulsion, and appropriate that is reverse and the forward stroke of the propulsion will have an impact on the direction. As far as low frequency perspective point of view, a low frequency wobbling phenomenon will be always observed, which is basically a kind of a misalignment in the axis of the symmetry. And the velocity perspective point of view, the velocity is proportional to the input frequency in the intermediate range. So, ideally in this particular case, A and B are related to the geometrical features of the helical system, and psi u contains the geometrical parameter of the head attached to this system. So, when we try to look into the structural design parameters, the key design parameters influencing the performance are the helical pitch and height, diameter and the cross section of the structure. So, in fact, this image will give us a better clarity where we have a filament diameter, there is an helix angle in place, a pitch, a diameter in place, and then the overall length which is being exhibited over here. As far as the structural design parameter perspective point of view, this magnetic helical system tends to sinks down or near to the solid boundary, which results in the kind of a lateral force due to the drag imbalance. The external applied non-fluidic force and torque must balance the fluidic force, and the torque generated by their rotation is represented by this equation, where it is considered that two sets of rotations or two sets of motions are taken into consideration. One is called as a translation and another one is called as a rotation. So, the drag coefficients involved in both translation and rotation are taken up into consideration for the head effectively, and A, B, C are related to the geometrical parameters which basically has a direct impact on the diameter, pitch, the length, the helical angle, the width of the filament diameter. So, the wettability of such kind of helical system is another factor that influences the locomotion, as an hydrophobic surface would cause a kind of a low drag force which exhibits over here. Now, let us see some of the key performance matrix of this system. So, some of the key parameters includes the propulsion speed which is in the range of up to 390 micrometer per second, and as far as stability perspective point of view. So, stability under the varying magnetic field is the strength, and efficiency in perspective point of view, efficiently in low Reynolds number environment is one of the key performance matrix. Now, let us discuss about the different modes of motion. So, some of the modes of motion of this particular systems are concerned. So, one is called as a straight mode system. As far as in this straight mode system is concerned, so we have a rotating shaft. So, with like without a tilted. So, when you try to move this rotating shaft appropriately, we get a displacement coming out of it. So, in this particular condition, so it is without tilted angle along the axis of the tube. So, this is a kind of a tilted mode. In the case of a tilted mode, so it is kept at a particular angle with a constant tilt angle along the axis of the tube. A wobbling mode is concerned, there is going to be a continuous change in the tilted angle. So, when there is a continuous change in the tilted angle, appropriately we get a highest efficiency in disrupting the biofilms and occlusion into the debris. So, as far as in this particular case is concerned, it can break down the biofilm into debris while enhancing the diffusion of antibacterial agents like reactive oxygen species, etc. So, these are the different modes of motion which exhibits over here. So, when we try to look into the material consideration perspective point of view, so we have the polymer materials in place. In the case of our polymer materials, so it is a kind of a silicon based polymer. So, technically we represent it as SU8. So, these SU8 offers an excellent mechanical stability, providing a thermal resistance. The cross-link SU8 structures remain stable during the development drying process as well as during subsequent metallization steps. Magnetic material perspective point of view, like nickel is considered to be one of the key material for actuation and control of helical micro machines, ideally in the range of 50 to 100 nanometer, and titanium, which is considered to be a kind of a biocompatible material which is in the range of 5 to 10 nanometers. Then since it is a magnetic, so Fe2O3 and Fe3O4 offer alternative acts as a kind of an alternative magnetic material with excellent responsiveness to the external field. These Fe2O3 based helical micro machines achieved magnetic saturation at 35 and electromagnetic unit per gram, enabling a rapid magnetic separation in aqueous environment within the seconds. Now, with reference to metal oxide perspective point of view, we have the zinc oxide, copper oxide, CO3, O4 and NiO offering a specific functional properties beyond the basic magnetic actuation. Graphene oxide perspective point of view, it acts as a structural framework combined with metal precursor solutions, and a high temperature processing perspective point of view, like it transforms the metal ion into a metal oxide structure that retains the helical morphology, exhibiting a catalytic and a functional property specific to each of these metal oxide types. So, ideally the material selection will fall under these particular categories. Now, let us discuss about some of the key applications of these magnetic helical micro machines. So, these magnetic helical micro machine can transport microparticles or biological samples in 3D environment using micro holders integrated into their structure. As far as application perspective point of view, the application are more focused towards targeted drug delivery and manipulation tasks. These kind of magnetic helical micro machines are well integrated with the cavities and carry drug to a specific location within the body. So, their precise control allow a localized delivery without damaging the surrounding tissue. As far as cell biology is concerned, it is used for manipulation of cells and biological samples, and as far as lab on chip is concerned, these microfluidic transport, it is highly useful for microfluidic transport and analysis. So, this is a kind of a configuration which is being deployed for a kind of a magnetic helical micromachines. With reference to medical integration with endoscopy, this endoscope assisted magnetic helical micromachines combining a visual guidance with precise magnetic actuation for biofilm eradication in sensitive structures like tympanic membrane and ocell is considered to be one of the key application of such kind of magnetic system. The system combines a helical microrobot and an endoscope, a magnetic actuation unit with a robotic arm and a kind of a specialized catheter. So, the endoscope is to visualize and deliver the helical microrobot via a catheter to the targeted site and remotely actuate the microrobot using a kind of a programmed magnetic field to perform the biofilm eradication task, which is considered to be one of the key challenges. So, basically this is a kind of a system, kind of a schematic treatment procedure for biofilm eradication in the for T-tube in a tympanic membrane under an endoscopic surgery. Now, let us discuss about the different fabrication techniques which are being used for such kind of magnetic helical based systems. So, one is a kind of a direct laser lighting which enables a kind of a precise fabrication of helical structure. Another one is through a physical vapor deposition technique, since we need to add certain amount of magnetic coating for appropriate actuation. Then there is also a possibility to have a kind of 2 photon laser printing, which generates a kind of a complex geometry with high resolution within the system. Okay. Some of the challenges and limitations involves like scaling up fabrication method for mass production while maintaining a consistent performance. It has a precise control and a localization, means it has an absolute position or error of 2.35 plus or minus 0.4 mm in the vitro models and 2.6 mm in ex vivo environments. Performance limitation perspective point of view, there is a difficulty of balancing competing requirements such as motion speed and drug carrying capacity. A stability of magnetic control system, it has a varying fluidic properties like temperature fluctuations, spatial constraints that impact the magnetic field uniformity and effectiveness. Biocompatibility perspective point of view, it is highly biocompatible, it has a good safety considerations and it has a reliable recovery mechanism. It also has a reliable retrieval method for safely removing from the task completions. So, some of the future trends of such kind of magnetic helical system is it enhance the biocompatibility for in vivo application, basically a kind of a biodegradable material that can safely dissolve after completing the therapeutic mission within the body. Integration with AI for autonomous operation, which aim to incorporate decision making capabilities that would allow the micro machine to navigate complex biological environments and respond to changing the condition independently. Exploration perspective point of view, it is used for exploration of new materials like graphene for improved performance, like smart materials that can respond not only to magnetic field, but also to the environment stimuli such as temperature, pH and chemical signal. Multifunctional capability perspective point of view, it is capable of sequential operation such as targeted navigation, a magnetic nanoparticle retrieval and programmed dual drug release, magnetic actuation with other stimuli like focused ultrasound and near infrared light to trigger specific functions at predetermined times, and significantly it also used for enhancing the therapeutic efficiency. So, these are some of the references. So, we will discuss about the manipulation for microsystem for microrobotic with reference to manipulation perspective point of view in the upcoming lecture.